This challenge is designed to exercise your skills with methods on arrays and array lists that are targets for Lambda expressions. First, I want you to create an array of string which is populated with first names in mixed case. Include at least one name which is spelled the same backwards and forwards, like Bob or Anna. Use arrays.setAll or list.replaceAll to change the values in this array. If you use the list methods, you'll need a list backed by the array so that changes get made to the initial array. In other words, I don't want you to make a copy of the array elements for the first part of this challenge. Using one of those two methods, perform the following functions on the elements in the array with appropriate Lambda expressions. Transform names to all uppercase. Add a randomly generated middle initial and include a period. Add a last name that is the reverse of the first name. Print your array or the array elements after each change using the forEach method at least once. Finally, create a new modifiable array list from your names array, removing any names where the last name equals the first name. Use removeIf with a Lambda expression to perform this last operation. You can create helper methods as needed to facilitate some of this functionality. You can use single-line or multi-line Lambda expressions. Ignore IntelliJ's warning and hints which prompt you to replace any Lambda expressions with method references. I'll be reviewing method references in the next video. Okay, so give that a try. When you're done or you get stuck, come back and I'll show you my own solution. Pause the video now. Okay, I hope you had a little fun with that. There are lots of ways to do these things, and I'll show you just a couple. I've created a new project called Lambda Expression Challenge. I'm going to be using the random class to facilitate my random middle initial, so I'm first going to set that up as a private static variable on my main class. I'm going to call it random and assign it a new instance of the random class. If you have some previous experience in Java, or you've explored solutions on the internet, you might have found examples using math.random. I prefer to start with this random class because I think it's a bit easier to use for new students. In addition, JDK 17 brought some enhancements to the random class, which make it even easier to use. It now implements an interface called Random Generator with several default methods, one of which is nextInt, which takes both a lower bound and an upper bound. Prior to JDK 17, this method wasn't available. In an upcoming section of the course, I'll be thoroughly reviewing both the math and random classes. Getting back to this code now, I want to create my array of strings called names. I'll use an array initializer with the values Anna, Bob, Carol, David, Ed, Fred, and Gary. These could be any names, but you want one of them to be a name that is spelled the same backwards or forwards, like Bob or Anna, which I've included. Maybe you used Ava or Hannah as alternatives. The challenge said you could use setAll on the java.util.arrays class or replace all on list to perform some of these operations. For the first one, I'll demonstrate an example of using setAll. In practice, it's more intuitive to use setAll when the generator function relies on the index of each element. However, setAll can also be used to retrieve and modify each element based on its index. Let me show you an example of that. Arrays.setAll, passing it names and a lambda expression. This lambda has I as a parameter and returns the element in the names array at that index but in uppercase. I'll print a heading and the names array. Let's check the results of running this code. You can see it changes all the names in the array to uppercase, so that's the first function in the challenge completed. I used arrays.toString to print this out here because I wanted to be very clear that the original array was changed. Another approach to manipulating an array of elements is to wrap it in a list and use the list methods. The list method, replaceAll, is conceptually similar to the enhanced for loop, where the variable being looped over is the element, not the index value. I'll create a list backed by an array next, so list of string, name backed by array, and that gets assigned arrays.asList, passing it my names array. Remember that creating a list like this gives you the ability to treat an array like a list, except for those operations that change the size, like remove or add. This is fun and handy for a lot of reasons, especially as we move into lambda expressions and streams. Before I go any further, I want to add two private static methods to my main class to make my lambdas a little easier to read. The first, getRandomChar, will take a starting character and an ending character as parameters. Let me set this up, then I'll explain it. So public static, and it returns char. It's named getRandomChar and takes a char, start char and another char, end char. Then I have a return statement that's calling random.nextInt. The nextInt method takes an inclusive lower bound and an exclusive upper bound to determine the range of random numbers to select from. I cast the characters to int, but I want to add 1 to the end character so that I can make the character passed to this method be included. Finally, this method returns an int, and hopefully you'll remember that you can cast a positive int to a char, which I'll do here. What this method does, if I pass A and E, for example, I'll only get letters that are between A and E, including E. This is a one-liner, and I could have included it in my Lambda expression. But in my opinion, I liked the way my code looked when I made this in a simple method. That's not a technical reason, is it? But sometimes aesthetics and readability matter. Okay, so the second method I want to add reverses the characters in a string. Again, this is a one-liner. I'm calling the method getReversedName, and it's got a string argument. I'll use a method on String Builder to do the work for me, so I'll create a new string builder, passing it my method argument, firstName. I'll chain a call to the reverse method on that, and then chain toString after that. Okay, those are my two helper methods. There are many ways to get a random character or reverse characters in a string. I like the simplicity and flexibility of these two options, but maybe you found others you like as much or more. Feel free to post your ideas in the Q&A section to share with me and your fellow students. I enjoy seeing the many varieties of ideas for these kinds of everyday tasks, and I hope you do too. Okay, I want to get back to the main method and use my list backed by array in conjunction with these methods to achieve the next couple of tasks. The first is to add a middle initial. I'll start by invoking replaceAll and define a lambda that has a single parameter s, a string in this case. I'm going to return a string concatenating the current name to the result of calling my getRandomChar method with A and D as arguments and a period added to the initial. And I'll just print the names again after a descriptive header. I will run that now. The result is some randomized initials, as you can see, with my uppercase names. Next, I want to add a last name, which is the first name reversed. Again, I'll call replaceAll on backed by array. This time, my Lambda expression will concatenate the name with the result of the getReversedName method I created earlier. I want to pass only the first name, excluding the initial. I'll print that out with a header first. Okay, so here, I do something similar, concatenating the result of my getReversedName method to the current name with a preceding space. Notice that I'm passing only the first name and not the initial to that method, and I do this by splitting the element name on spaces, knowing that the first element is the first name. Next, instead of using toString on arrays to print my array out, I want to use the forEach method. You can use this method on any array by first wrapping it in a list backed by an array, so I'll do that, rather than simply calling it from the local variable, just to show you how you might do this with any array. If you want to leverage the forEach method to do anything with your array elements, this is a simple way to do it, by chaining the forEach method to the arrays.asList method. One of the objectives of this challenge was to use the forEach method at least once to print the elements. If you used it directly on your local variable, that's perfectly fine. I just wanted you to see how to use the forEach method on elements on an array in this manner. I will run this now. I get my names, including last names, as well as middle initials, and now they're listed one on each line, because I use println in the Lambda expression. The final part of the challenge was to remove names that have the first name equal to the last. In my example here, that's both Anna and Bob. A list backed by an array will throw an exception if you try to remove elements with the remove if statement. This means that now I want a list that's not backed by the array. I'll set that up next, so I'll create a new list and assign a new array list to it, passing it list.of with names. I could have just passed my local variable, the list backed by an array, to that constructor, which would also result in a list with new members. There are usually multiple ways to do one thing, and not really a perfect right way. Now that I have a copy of the names, I can execute the remove if method on this list. I'll pass it a Lambda expression with a predicate. Remember, a predicate evaluates to a true or false result. Here, I'll compare the first part of the name, up to the first space, with the last part of the name from the last space to the end of the string. Any name where this condition is true gets removed from the list. I'll again use forEach to print each name on its own line. Running that code. You can see my copied and altered list printed out, and Bob and Anna are no longer in it. Okay, so this code meets all the requirements of the challenge. Maybe you used multi-line Lambda expressions to do some of this work, and that's also perfectly valid. Let me demonstrate an example of that now to reinforce a couple of points. I'll change my remove if statement to be a multi-line Lambda. First, I'll copy what I have and comment out the first occurrence. I'll next add an opening curly brace after the arrow. I'll replace the first closing parentheses on the third line with a closing curly brace. Notice I've got an error here, but I'm not done yet. When you use a code block in a Lambda expression, you need semicolons after each statement. This is an easy thing to forget. You also need a return statement if the target method has a return type. The return statement is implied for a Lambda expression that doesn't have a code block. I'm going to set up some local variables next. The first will be set to the first name, and then last gets assigned the second part of the statement. Now I've got two variables, but I need to return a Boolean which tests if first equals last. Because I'm using a code block, I need to specify the return statement explicitly, so I'll return first dot equals last. That's a multi-line Lambda expression. If I run this now, I get the same results as before. Many developers, me included, prefer writing code in the most concise way possible, even if it sometimes sacrifices readability or efficiency. When working with a large number of transformations, it's important to balance conciseness with performance. It's always a trade-off. I hope you enjoyed this challenge and you're looking forward to using Lambda expressions in your Java code. In the next video, I'm going to cover method references, which are shortcuts for certain types of Lambda expressions, so I'll see you in that next video.